Good morning, sixth graders. Mrs. P here. And today I want to talk to you about inequalities. I want you to think about inequalities in the sense of equations as one side of a mathematical statement is going to have something to do with the other side of a mathematical statement. So there's going to be some kind of relationship there when we're looking at inequalities. Now, the huge difference between inequalities and a standard equation, and I kind of want to go through this with you. Let's look at expressions, equations, and now inequalities. I want to look at those and kind of go back over what sense do we get on how they're different. Remember, an expression is just a mathematical phrase. It's not a complete statement. We don't know if we're answering it yet or not. It's just giving us an idea of what's going on mathematically. So it's just a mathematical phrase. It's not quite complete. What are we going to do with it? What should we do with it? An equation is a mathematical statement because we now know that it's complete. 7 plus C equals 10. So we can then figure out what that C is. So in an expression, we're not for certain what we're looking for. We don't know if they want us to answer it. C can be anything. We can just make it up on our own. It can be 5. It can be 7. Any solution could be possible because we aren't even trying to have a solution. We're not trying to solve that. In an equation, though, the left-hand side must be equal to. So the key word in an equation is right here. It must be equal to my right-hand side in an equation. This mathematical phrase is equal to this mathematical phrase, which allows it to be a mathematical statement. Now, our big thing for today is, well, how is that different than anything we're going to be dealing with when we talk about inequalities? We're in inequality still thinking of equal as a root word in an inequality. But what makes it different than an equation, if it's especially with the root in and the TIES at the end? And that has to do with the fact that an inequality is a statement that compares something as in putting it in. So inequality meaning attributes, character traits, if you kind of want to relate those kinds of things together. What are the possible solutions for that? What are the examples of your character traits? What are the possibilities that would make this a complete and true statement? So an inequality then looks for possible solutions. And if we're looking for possible solutions, we can't use just the equal sign because the equal sign means definite. There's a complete true answer. 7 plus C equals 10. C has to be a value that will give me back 10. So in this case, C has to be 3. There's nothing else that C can be for me to get 10. Well, in an inequality as an equation, per se, means that I'm looking for all the possibilities of that. And the way we look for possibilities is by comparing things. And comparing, we know, are greater than or less than objects, numbers that will make our solutions true. But in inequalities, you can also use greater than and equal to, or, well, less than and equal to, greater than or equal to, or you can even have that it's not equal, not equivalent. And we've talked about that mathematical symbol before. So in an inequality, the big word that you want to remember here is that it's a comparison of one half of the expression to the other half of the expression. Again, it will make a mathematical statement, but it has numerous possibilities. It has numerous solutions. So the big word here is to remember that this is a comparison. Comparison is a big thing that you need to remember here, that we are comparing things in an inequality. So I'm going to compare one half of my expression to the other half of my expression in my mathematical statement by letting myself know if it's greater than less than, greater than, whichever way it's pointing, wherever the number is. Greater than, less than symbols, and then a line underneath it means that it can be less than and equal or greater than or equal. I always let students know that this little symbol here, these less than and greater than signs, really started off as these. Lots of kids like to say they're the alligator things, but I always want them to understand that these symbols were really originally equal signs. And it's just dependent upon when you said that you knew a numerical value was greater than 5. So instead of us putting that equal sign there, because of the value being larger, we then change that to greater than. That is how those symbols work. So less than, greater than, and it depends on how you say them, on which way you're looking at the numbers. Lots of people like to keep this as less than and greater than, moving to the right as larger. But I tell kids, really, state it however your number is. If I want to say 10 is greater than 5, that's awesome. Or I can go 5 is less than 10. Just make sure that wherever it's pointing to, what numerical value is pointing to, you use the correct terminology, the correct words. All right? So this is what an inequality pertains to. A comparison of using less than, greater than, or maybe it could be that you have a solution that is less than, but it could be equal to, or it could be greater than or equal to, or maybe you can never find a solution to that. So I'm going to run through a few of these today, hopefully quickly, not another 20-minute video. I'm going to run through a few of these today just to show the students how we come up with solutions of those. And sometimes when they ask us about inequalities, they're not asking you to give every solution, but they're asking you, do you know a possible solution to this inequality? So I'm going to erase this. Before I do, you know me, I'm going to reiterate. An expression, a mathematical phrase. There's no solution needed for it. They're not asking you to answer it. They're just letting you know this is a mathematical phrase that you could possibly answer. You could make C whatever you wanted it to be. In an equation, the left-hand side must be equal to the right-hand side. So anything in algebra that you're using as a variable, that variable then must make this mathematical statement true. So now we're going to look at inequalities, where we're now looking at, can the left-hand side be less than or equal to the right-hand side? Or can the right-hand side be greater than or equal to the left-hand side? Or can they never be equal? Can there never be an equivalence? Can I never find a solution for that problem? We're looking at comparing these numbers. So let's go ahead and try some of these. I'm going to leave that word up there just so we know what we're focusing on. And I'm going to go ahead and put these symbols back up there so that when we're working with these, we know what symbols we could possibly use. And I'm even going to number them as 1, 2, 3, 4, and 5, just so you know that there are 5 different possible mathematical symbols that we can use to make these statements true, okay, with a number of solutions. So again, for the students, they can look in their math book and they can use these hard copy. So if they want to get practice in, they can be using these hard copies. These things start, or inequalities, I better stop calling them things. Inequalities start on page 465. And in the beginning, it's just talking about what an inequality is and how you find a solution for an inequality. I'm also going to combine that with lesson 8-9, which starts on 471 and goes all the way to 475. So it's talking about solving an inequality and then writing an inequality, which is the same thing as what we did when we were talking about equations. Can I solve an equation? Can I write an equation? You're going to do that same thing with an inequality, only now with an inequality, there may be numerous possibilities for your solutions in solving those problems. So we're just going to begin. I always feel like it's sometimes really better to start with the writing process and then turning it into an inequality and then seeing if you can answer it. So that's where I'm actually going to start because I think that's better for the students. And I'm just going to take some examples here from the book. So one of the first ones says the height which is going to be recognized as the letter H, is greater than 2.5 meters. Now, the reason I feel it's better to start with the writing is then when students see the inequality, then they can state it. We should always be able to read math. And when I say read math, I mean we should be able to talk it out. We should be able to state what it says. So I always like starting with the writing process first. I think that's good for students, for reading and writing and literacy. Then to turn things into mathematics, into a mathematical statements that they then can solve because they know the words that they used in order to write it and then solve it. So it says the height, which is H. So I know right here, here's one piece of my mathematical statement. I'm just going to make it the left-hand side. H. And it goes on to tell me that H is greater than. So here's another piece of what I would call my word problem, greater than. So I know that the greater than symbol, as the students will tell you, is alligator. The open part means that it is the greater, that it will extend on. It will be your largest number. So if I want to say greater than, I will point my comparison symbol, in this case, to my right, where I'm then going to put 2.5 meters. M as in meters for our metric system, which the students have done. And this is how I would write my inequality. I've read it from words, the height. And this isn't italicized in your book, and normally, you know, whether they put parentheses or something around it so that it'll denote that that's variable you're supposed to be using. The height, H, is greater than. I must know what greater than means. Larger than 2.5 meters. And then I can see this inequality, and I can ask myself again, now can I read it? If these words were gone, could I read this inequality? H is greater than 2.5 meters. Now, if they wanted me to solve this, I could go on and do that. And this is where you have possibilities for numerous solutions. If I ask you what H is, I can then say H is equal to, and I'll tilt that down a bit, H is equal to anything that is bigger than 2.5. Anything that's larger than 2.5 would be my answer. I could say H is 2.6. I can say H is 5. This is really what some will say is the greatness about inequalities. You have a chance to make many solutions. You have the possibility to be right more times than you are not with an equation. So this is what we do with inequalities. Take it from the word form, put it into the numerical and algebraic value for a mathematical statement, and then see if we can solve it. Now again, sometimes they'll give you the value of H, and you have to say yes or no to that. Or other times we want you to find what the value is. Simply what I did here. I know that my H has to be bigger than 2.5. I can use anything that's bigger than 2.5 to come up with that answer. So I'm going to do another one of those, word form, then to the mathematical statement, and then I'm going to do some practice solving them. So let's do another word form. Again, I'll take this, and I want to do this one because it'll give you more of an insight of how the other symbols can work. It says the temperature. Oopsie, left a letter out. I knew I was going to. The temperature, T, is less than or equal to a negative 3 degrees. Now this encompasses quite a bit for the students to figure out. The first part they can definitely say is the temperature T. So they know they're using the variable, algebraic variable of the letter T. They know it's then going on to say that it's less than. So it's less than or equal to a negative 3. So that means that the temperature has to be less than. And in this case, the less than is a negative. So for students, they know that if the negative is bigger, it means it's less than. So for me to say that T is less than or equal to a -3 degrees, my options here are that it says it can be less than or equal to. That's what they take off this portion so that you'll know it's less than or it can be equal to. They use 1/2 of the equal sign because the other part is that it can be less than or it can be equal to. So right now, I know for definite that T can equal a -3 degrees. How do I know that? Because the problem stated that the temperature T is less than or equal to a -3. So my T can represent a -3, or my T can represent anything less than a -3. Now in this case, a -3 means if I want anything less than a -3, that the number that is a negative must be bigger, because the bigger the negatives, the more they're worth less. And I always tease kids, don't say worthless like, oh, that's worthless, but as in value, it means it is worth less, 2 words, not a compound word, worth less in negatives. So my T would then have to be something like a -4, a -5, a -6 degrees, because those temperatures are less than a -3. Hopefully that makes sense for the students. And if not, then they'll question and email me and ask me, or parents, you'll question or email me. So this is 2 examples of taking these words to, ladies and gentlemen, mathematical statements. After that, we can then try to solve inequalities. That's back in lesson 8.8, but I really like doing the words first so that kids can read through them. So then we can go back to 8.8, and then they'll give you inequalities, and they'll either give you a value for it and ask if it makes it true, or they'll leave it blank and ask you to then solve it and see if it's true, such as P is greater than a -12. Well, I know my P must equal anything that's greater than a -12. A -11 is greater than a -12. Why? Because its value is not as bad in the negative sense as a -12 is. So that's an easy, simple way to answer it. They'll say P is greater than a -12. What is P equal to? Well, P can be -11. It can also be anything greater than a -11, as in greater coming back to my 0, coming back to my 0 on a number line. Or there might be times where they ask you something like X is less than or equal to 3. Can X equal 3? So they said X is less than or equal to 3. Can X equal 3? Well, in this case, that's true. Yes, X can be 3 because they said X can be less than or equal to 3. So if I plugged in X as a 3, is 3 less than or equal to 3? Absolutely. I could also say X is equal to 2. Would that make the statement true? Well, absolutely. Is 2 less than or equal to 3? Well, yes, 2 is less than 3. And so that's the beginning information of inequalities. Inequalities are nice for students. Well, in general, it's nice because it's math, and everything math is nice for students. But inequalities are nice for students because it gives them the option of a number of solutions. They just must remember when you're using these symbols of greater than or less than or equal to or not equal to, and I forgot to put my line in that. Well, I could just give 6. Not equal to. They must remember how it's stated using mathematical terminology. And then they must be able to see if they can solve that by using that comparison of greater than, less than, or equal to in their statements. So I really like the kids to take a look at that today or over this week, our inequalities, and see if they could figure out what makes this statement really true. What makes these inequality mathematical statements true? What can I use as a solution for the variable that will make it greater than, less than, greater than and equal to, less than and equal to, or not equal to at all? That's the beauty of inequalities. If you have questions, please let me know. Otherwise, I'll see the kids back on Thursday this week, which will be the 9th of April, right before we take a break for Easter holiday. Until then, have a great day. I really, truly Miss the kids. Wish we were in the classroom, but we're doing all right. And eventually we're going to get back there. Have a great day. I'll talk to you later.